Bismillahirrahmanirrahim. We are still in this topic, the L'Hopital rule. And this is the fourth part of this topic. We say that the L'Hopital rule is just a finite limit when there are some conditions must be satisfied, especially for the rational functions. Just as a reminder, for the L'Hopital rule said that the limit function f of x divided by g of x as it goes to some number is equal to the limit of the derivative divided by derivative of the denominator as x goes to a. Provided that the limit of f of x equal to 0 and g of x equal to 0 or infinity over infinity. This is if it is either 0 over 0 or infinity over infinity. And we call these two forms indeterminate forms. And in the previous part, we discussed these cases 0 over 0, infinity over infinity, infinity minus infinity, 0 multiplied by infinity. For today, we are going to discuss the cases 1 to power infinity. Also, we have this one. We'll try to discuss this form. 1 to power infinity, how to find the limit of this case. Let's start our examples. Example number 1 is say use the L'Hopital rules. Find the limit. Number 1. Let's find the limit of e to power x plus x to power 1 over x as x goes to 0. If you replace x by 0 in this function, you will have something like 1 to power infinity. It's indeterminate form. And we need to find the limit. We mentioned this in the exponential function that if we have a function, that's the other remark, f equal to f of x or g of x, then take length. Take length to find the limit, or in that topic, we say that take length to find the derivative. Now for this, because we need to find the limit, we'll take length to make it easier to find the limit of the function. Because I have function to power another function, so I will add len to the both sides. Or okay, let's say that I will let y equal to e to power x plus x to power 1 over x. So if we take len, that will be len of y equal to len e to power x plus x or to power 1 over x. And using the properties, it will be 1 over x multiplied by len e to power x plus x. So len of y written as len of e to power x plus x divided by 1, divided by x But the question say that find the limit. We need to find the limit. Limit of all of these, len of y equal to limit len of e to power x plus x divided by x as x goes to 0. On the right hand side, you can see that if we replace x by 0, I will have 0 over 0, which means the condition for the L'Hopital rule is satisfied. I have 0 over 0, so we can apply the L'Hopital rule for the left hand side. I'm sorry, for the right hand side. So by the L'Hopital rule, this is equal to limit x goes to 0 of the derivative. Derivative of len is e to power x plus x down, and the derivative of the function is up. That will be e to power x plus 1. Divided by derivative of the denominator is equal to 1. Derivative of len is f prime divided by f. So it is e to power x plus 1 divided by e to power x plus x divided by the derivative of the denominator, which is equal to 1. Now, if we replace x by 0, I will have e to power 0 plus 1 divided by e to power 0 plus 0, and that will be 2 over 1, or it is equal to 2. So the limit of len of y equal to 2. But let us just go back to the question. In my question, there is no len. This is not part of the question. We added in this step to find or to make the function easier. Now I have to take that len out. We added len, which is not part of the problem. Now I have to remove it. So what we have now, we have limit of len y equal to 2. There's one thing, that limit and len can be reordered. Len and limit, they are commuting. So I can write it as len of limit. We can reverse the order of the limit and len. Len of the limit equal to the limit of the len of y is equal to 2. All what I need now, just to convert the logarithmic form to the exponential form. This means the limit of y as x goes to 0, this is len. Converted to the exponential form, it will be e to power 2. So the limit of this function, limit of e to power x plus x all to power 1 over x as x goes to 0 is equal to 2. I'm sorry, it is e to power 2. So this is the answer. Again, if we have exponential to power another function to power another function, take len to make it easier, then try to find the limit. Let me take another example. Number 2 is the limit of 1 minus cosine x or tangent. As x goes to pi over 2. Direct substitution for 1 will give me 1 to power infinity. So to find the limit for this one, say let y equal to 1 minus cosine x to power tangent. Now ln of y will be tangent multiplied by ln 1 minus cosine x. Take ln, put the power down by the property of the logarithm. It is tangent x multiplied by ln of 1 minus cosine x. And we know that the tangent is equal to cosine sine divided by sine. Sine divided by cosine. So this is equal to sine x divided by sine x multiplied by ln 1 minus cosine x. Or just simply converting as ln of y equal to sine x multiplied by ln 1 minus cosine x divided by cosine x. This is ln of y, and we need to find the limit. The limit of x goes to pi over 2 equal to the limit of this function. Sine x multiplied by ln 1 minus sine x divided by cosine x. Limit of sine x multiplied by ln of 1 minus cosine x divided by cosine x when x goes to pi over 2. If we just substitute x by pi over 2, I will have 0 over 0, which is the condition of the L'Hopital rule. I got 0 over 0, two functions differentiable at x equal to 0, and we got this form 0 over 0, which is one of the indeterminate forms. The condition is satisfied, so I can apply the L'Hopital rule. By the L'Hopital rule, this is equal to limit of. For the numerator, I have to apply the product rule. That will be f prime g plus g prime f. That is cosine x multiplied by ln 1 minus cosine x plus derivative of ln. The function is down, and the derivative is up. Sine x divided by 1 minus cosine x multiplied by sine x. Okay, this is f prime g, and this is g prime f. Divided by the derivative of cosine, that will be minus sine. As x goes to pi over 2. So now let's try to substitute, replace x by pi over 2. Cosine pi over 2 is equal to 0, so this one will be 0. This part down will be 0. Sine of pi equal to 1, and this is 1. Down is minus 1, which means the limit is equal to 1 divided by minus 1, which is equal to minus 1. But again, this is the limit of the len. This is the limit of len. Len is not part of the problem. We added, so we have to remove it. As x goes to and side can be written as len of limit y as x goes to y over 2 is equal to minus 1, which means limit of the function that 1 minus cosine x to power tangent is equal to, just convert the len to the exponential form, it will be e to power minus 1. So the limit of this function is equal to e to power minus 1. Limit of x as x goes to y over 2 of 1 minus cosine x to power tangent equal to e to power minus 1. Let's take one more. Number 3. Limit of x plus 1 to power 1 over x as x goes to stake 0 plus. Again, we have function to power another function. And if we replace x by 0, or just approaching 0 from the right, this will be 1 to power infinity. So let's apply the same technique. Let y equal to x plus 1 to power 1 over x. So len of y will be 1 over x multiplied by len x plus 1. Or it can be written as len divided by x. Now the limit of len of y x goes to 0 equal to the limit x plus 1 divided by x as x goes to 0 plus. It is very clear that this is 0 over 0, satisfying the condition of the L'Hopital rule. So by the L'Hopital rule, this can be written or is equal to derivative of len is 1 over x plus 1. Derivative of x is equal to 1 as x goes to 0 plus. I have 1 over x plus 1 divided by 1. Replacing x by 0, I will have 1. But again, this is the limit of len. Limit of equal to 1. This can be written as len of y, len of the limit. Equal to 1 as x goes to 0 plus, which means limit of y is equal to x plus 1 to power 1 over x equal to just convert the Lagrange to the exponential form, and that will be e to power 1. So the derivative, so the limit for this function is equal to e to power 1. Limit of x plus 1 to power 1 over x as x goes to 0 plus equal to e to power 1. So this is how to find the limit of this form or the indeterminate form 1 to power infinity. And these are 3 examples how to find this type of limits.